Hello and welcome to EGN 3613. In previous sessions we started with simple interest rate. Then we learned about the compound interest rate, and we said that we will use from now on we will use during the semester and during our calculation the compound interest rate. The symbol was just to introduce the value of the interest rate or the terminology of interest rate. But after that we started calculating the equivalence value of the future, or how to bring the future to the present value using a compounded interest rate. We learned also how to calculate annuities. The annual interest rate, which is called APR, is not the effective interest rate, and we need to calculate that based on the payment period and the interest period. The annual interest rate is different than the effective interest rate. Now in this session we will consider and include inflation in our calculation. So we did the symbol, we did the compound, and then we learned that the APR is not the one that I'm looking for. I have to calculate the effective interest rate and use it for calculating the future value or the present value or the annuity. And in this session we'll add another factor, which is the inflation, for our measurements or our calculations. We will address measure of inflation. We will also address actual versus constant dollars, and then we will address equivalence calculation under inflation, and I will separate each one of these in a different session. So we'll talk about the inflation first, then the actual versus the constant dollar, and then we will address the equivalence calculation under the inflation, how it can be done. So let's start with first talking about the inflation. What's inflation? If you remember, in the first lecture in chapter 2 we introduced inflation and taxes. At that point we defined inflation as the decrease of the currency purchase power, or that the currency will worth less over time. But how can we measure inflation, and how do you incorporate the effect of inflation in equivalence calculation? This means that inflation will decrease purchasing power. You need more money to buy the same amount of goods and services. And the increase in purchasing power, which is the opposite, is called deflation. So if you could actually buy more with the same dollar, that's called the opposite of inflation, which is deflation. And we'll talk about both of them in a minute. So we can understand the purchasing power by looking at the number of Big Macs that you can buy with $100 in 1990, which was 50 Big Macs, compared to 2003, where you can buy with $100 40 Big Macs, which means that the $100 in year 2003 has only $80 worth purchasing power of 1990. While on the other hand, you can look at an example of deflation when you compare the price of gas between the year 2003 and 2004. In 2003, the gallon of unleaded gas was $1.57, compared to 2004, when it went down to $1.25 per gallon. Which means that the $100 in 2003 could buy 63.69 gallons only, while the $100 in 2004 can buy 80 gallons of the same gas. And this is what we call deflation. To measure the inflation, we can use two different price index indicators. The producer price index, which is a statistical measure of industrial price change compiled monthly by the Bureau of Labor Statistics, U.S. Department of Labor, and the consumer price index, which is a statistical measure of change over time of the prices of goods and services in major expenditure groups, such as we're looking at the food industry, the housing industry, the apparel, the transportation, healthcare. All these areas has products that can be measured because of the changes that will happen to the price over time. Using these indexes, actually we can measure the average inflation rate and the general inflation rate. The average inflation rate is defined as a single rate that accounts for the effect of varying yearly inflation rates over a period of several years. So we look at what's happening to the inflation every year, and then we can take the average for several years. The general inflation rate, or we call it F prime. So this is called F prime or F average, and it's defined as the average inflation rate calculated based on the CPI for all items in the market basket. And when we say the market basket, means the group of items that's related together, that's put in one place on one basket. Let's look at the consumer price index, the CPI. To measure the inflation, the consumer price index compares the cost of a sample of product in a specific period relative to the cost of the same product in an earlier period. And this is what we are trying to find, the change in the price of that product. This reference period is designated as the base period. So whatever we decide that this will be the base period, that will be my designated period or my reference period to the price. For example, if the base price of year 0 is equal to 100 and we had inflation of 4% for the first year, then 8% in the second year, what will be the average inflation rate over 2 years? If you look at this example and see that we have the first year of 4% inflation, the second year of 8%, anyone will add both and say, okay, the average is 4 plus 8, which is 12 divided by 2, that's 6%. So the average of the 2 years is 6%, which is incorrect. That's incorrect. So how can we find the average inflation rate over the 2 years? To do that, we have to use the formula. And we have to consider the interest or the inflation per percent. So it's 4% the first year, and then whatever we had the first year will be taken the second year with the 8%, and that's how we get the change. So if you do that, then the actual inflated price from year 1 to year 2, or from year 0 all the way to year 2, will be $112.32. So $112.32. So from 100 it went to $112.32. Now to find the average inflation rate by solving the equivalence equation, if you remember, when we used to have F is equal to P, the present value, multiplied by 1 plus the interest squared. And the interest or the inflation here is the average rate that I'm looking for. So I'm trying to find the value of the interest over, or the average for the 2 years for the inflation. So using the formula, and I have here 2 years, then we get F as 5.98%. So it's not 6% as we anticipated. It's different, and maybe someone will say that the 2.02% is not that much of a difference. Actually, it makes a difference, especially when you have big amounts of money. That's why we need to take into consideration any digits after the period. The table in this slide provides an example of specific products' average inflation rate. So if you take the first row, assuming that we have the postage with a price of 39 cents in 2006, while its price was 33 cents in 2000. What's the average inflation rate for that specific product? Using the formula, the price of earlier year is the price of earlier year multiplied by 1 plus f to the power n is equal to the price as or in a later year. Using the mathematical calculations with n equal to 6 periods, since I'm moving from 2000, the year 2000 to the year 2006, those are 6 years, and the cost from 33 cents to 39 cents, we use the formula and we apply it, which is the price of 0.33 multiplied by 1 plus f to the power n, and n in this case should equal to 6, will equal to 39 cents. And from there you should get the value of 0.0282 or 2.82%. You should get the value of 2.82%. And you can try and verify the other products shown here and look at the average inflation rate for each one of them. We can use the consumer price index to calculate the general inflation rate, F average or F prime. This average inflation rate is calculated on the basis of CPI or consumer price index. That's why it's different than the average inflation rate for specific product, where CPI at year n is equal to CPI at year 0 multiplied by 1 plus average inflation to the power n. So the general inflation rate will equal to CPI n divided by CPI 0 to the power 1 over n, all minus 1. Let's look at this example. Calculating the inflation rate for each year, then the average inflation rate over 3 years. The inflation rate during the first year is 538,400 minus 504,000 divided by 504,000. And that will give us 6.83%. We'll do the same for the second year, subtracting the second year value from the first year value divided by the first year, and that will give us 7.17%. The same for the third year, and I will get third year minus second year divided by second year, and that will give me 9.1%. So the average inflation rate over 3 years is the last cost divided by the first, or the cost at year 0 or the base, to the power 1 over n, and in this case I'm dealing with 3 years, So it will be 1 over 3 minus 1, and all that will be equal to 0.0769 or 7.69%. And again, we did not find the average by adding all three values and dividing by 3, but actually through the calculation of f using the formula. And this is the average inflation rate over 3 years. This will be all for this session. If you have any questions, you can use any of the communication channel to send it to me, send your concern or your question, and I will be more than glad to answer it. Thank you and have a great day.